trig functions. You should know these rules. They're very straightforward, nothing special. The limit as x goes to c. I'm going to use some shorthand notation. Trig of x. This equals trig of c. What does that mean? That means replace the word trig with any trig function you like sine. Sine of x, the limit as x goes to c of sine of x equals sine of c. Replace trig with cosine. The limit as x goes to c of cosine of x equals cosine of c. This is true for all 6 trig functions. For example, the limit as x goes to not c, say 0, of cosine of x, well, this is cosine of 0, which happens to be 1. You need to know cosine of 0. You need to know cosine of pi, etc. The limit as x goes to pi of cosine of x, this is equal to cosine of pi, which happens to be negative 1. No matter what the trig function is, the limit as x goes to c of that trig function of x is equal to that trig function of c. Doesn't matter what the trig function is. I am not saying that you can replace that trig with sine and this trig with tangent. No. They have to be the same. The limit as x goes to c of tangent of x, well, yes, that equals tangent of c. With the normal, straightforward trig functions, that's all it is. And you have 2 special trig functions that you should know. The limit as x goes to 0 of sine x over x. Well, by what I just said. So a fraction, a limit of a fraction is the limit of the top, which will be sine of 0, divided by the limit of the bottom, which is 0. Now the sine is 0 is 0, and 0 is 0. So we have 0 over 0, and there's L'Hopital coming in. The derivative of the top is cosine of x. The derivative of the bottom is 1. In fact, I'm pretty sure we did this one. Cosine x over 1 is just cosine x. The limit as x goes to c of any trig function is, in this case, is cosine of 0. Because it says 0 there. And that's 1. That is, after all that writing, that's 1. And we should know that. Now let's look at that a little bit more closely. Let's look at that one a little bit more closely. Sine x over x. The angle and the denominator, they're the same. That's one thing we notice. And as x goes to this number, these both go to 0. That's 1. For example, if I had the limit of the sine of x take away 2 divided by x take away 2, and I take the limit as x goes to 2. For this to equal 1, 2 things have to be true. The angle, and in this case the denominator, they have to be the same. And they are, which is good. It passed condition 1. They're both the same. And when x goes to that number, both of these are equal to 0. 2 take away 2 is 0. That's 1. The limit as x goes to infinity of sine 1 over x divided by 1 over x. when I'm taking the sign up and the other side of the division line, they're both the same. It met condition 1. They're both the same. Condition 2, when x goes to infinity, both of these go to 0. 1 over infinity is 0. Oh, that's 1. Okay, but just for the record, that's also the same as the limit as x goes to infinity of sine 1 over x. Now, instead of dividing by 1 over x, we could multiply by the reciprocal. That is, if somebody gave me this problem, I would think this problem. Then I would say, oh, these two are both the same. These two are both the same. And as x goes to infinity, they both equal 0. Those are the two criteria for a limit like that to equal 1. Now remember that the limit as x goes to any number, hold it C, of a constant times a function, the constant can come out in front. The constant can come out in front. Okay, just keep that in mind. So now, if I ask you, what's the limit as x goes to 0 of the sine of 5x over x? Well, it didn't meet condition 1. For us to say that this is 1, it didn't meet the conditions. Those two are not the same. They pass condition 2. When x is 0, 5x is 0, and x is 0. So what we're going to do is we're going to put the 5 in. Here's the 5. Now, these are the same. But to put a 5 in the bottom, you have to put a 5 in the top. And we invoke the rule right above. That 5 can come in front. This limit is equal to 1. Why is that? Because both of these are the same. And when x is 0, both of these are 0. So the answer is not 1, but 5 times 1, or 5. Just for the record, the teacher may not allow you to just do this, but just for the record, you can read the answer off as follows. You can just read it off. Sine of 5x over an understood 1x. There's your answer. The answer is just 5. Let's actually show that in general. Just read off the answer. Now, I'm going to use A and B, and I want you to realize that regardless of what A and B are, this is going to work. Suppose you have the sine of AX divided by BX. Well, you can't move that A in front, but you can surely move the B in front. This is equal to 1 over B, because the B is in the bottom. The limit as x goes to 0 of sine AX over B. Excuse me, over x. You put the B in front of x. Now, I want these two to be exactly the same, which means I have to put an A in the bottom, which means I have to put an A in the top, say right there, but we're allowed to move that in front. Okay. So we have A over B times this limit. But that limit is 1. That limit is 1. Why? Because both of these are exactly the same, and when x is 0, both of these equal 0. It is the final answer is A over B. It's just that. It's just A over B. You want to put numbers in, you put numbers in. Wherever you see A, put 3, and wherever you see B, put 4, for example. 3 over 4. Well, the first thing you should do is pull that 4 out in front, which is in the bottom, so you pull it out as a quarter. Let me continue to write that in red. But A is 3. So you want a 3 on the bottom, so put it. There's this 3 on the bottom. But then you have to put a 3 on the top. And there it is. What's in the big box is 1. Again, this and this, they're equal to one another. And when x goes to the number 0, both of these equal 0. That's 1. It's 3 over 4 times 1, which is 3 over 4. So here's a nice way of just knowing the answer beforehand. The answer is 3 over 4. Of course, 3x and 4x, well, x has to be going to 0. So now you can just read off the answers. A slight modification would be the following. The limit as x goes to 0 of x over sine x. Well, again, L'Hopital would see, what you can do is you can say this is what can you do? Okay, what you can do is the following. You can take the reciprocal of this and then take the reciprocal again. So this is equal to the limit as x goes to 0. I take the reciprocal. I take the reciprocal. I get sine x over x. That took care of that inverse. And now to the negative 1 power. All right. So now limits limits have this rule. You can take the limit as x goes to 0 of sine x over x, and instead of taking the reciprocal of just that, you can take the reciprocal of the answer, of the limit. But that limit is 1. And when you raise it to the negative 1, you still get that 1. It didn't change. That's the whole story. As x goes to 0, x over sine x equals 1. Lots and lots of students think, oh, sine x over x is 1. That is not true. Sine x over x is not 1. As x approaches 0, it is. So if you were asked to find the limit as x goes to c, make that 0, of ax over sine bx. Question is that going to just be a over b? Well, who knows? Let us get our hands dirty. What you do is you bring the a in front. X over sine bx. And you put a b in the top and you put a b in the bottom. Same rule. If both of these are the same, which they are, and as x goes to 0, both of those equal 0, that limit is 1. This limit is 1. So you have a over b times 1, which is a over b. Here, the answer is right there. You could read it off. If your teacher allows that, that is, you're just able to say a over b, boy, did I make these problems easy. That is, if somebody asks you what's the limit as x goes to 0 of 17 over the sine of 33x, you say 17 over 33, and you should get full credit. If you know, whether you get full credit or not, this here is the answer. The instructor may want you to show some work. That's between you and your teacher. Okay, I promised you that there were two special limits. The other special limit is the following. It is the limit as x approaches 0 of, I guess, 1 minus cosine x over x. If you plug in 0, cosine of 0 will be 1. So 1 minus 1 is 0, and the bottom is 0. Well, this is equal to the limit as x approaches 0 of the derivative of the top. The derivative of 1 is 0, minus the derivative of cosine x is negative sine x over the derivative of x is 1. So this here is just sine x. Sine x over 1 is sine x. So we plug in 0 for x. We plug in 0 for x because it tells me to. And the sine of 0 happens to be 0. That is, this limit is equal to the number 0. Limit comes up, I think, in the derivation of either finding the derivative of the sine of x or the cosine of x. I guess I would lean towards the cosine of x. If you are asked to find the limit as x goes to 0 of 7 times 1 minus cosine of x over 3x, you should say the answer is 7/3 because you can factor out the 7/3, and that's not the reason why the answer is 7/3, but we know that this limit is 1. 7/3 times 1 is 7/3. 7/3 times I don't know is not 7/3. You better confirm that that's 1. And then you can say it's 7/3. Suppose you have this limit. Suppose you have the limit, change the variable t. T goes to 0, sine 7t squared over 3t squared. Now, before we do that, let's just look at this one. Limit is t goes to 0, sine t squared over t squared. Both of these are the same, and there's a sign in front of one of them. And when t is 0, both of these are 0, that equals 1. This one equals 7/3. For the same reason as always. That's 3 in the bottom. I'm going to pull out in front as a 3. I'm going to put a 7 in the bottom, and I have to put a 7 on the top. Since both of these are now equal, and when t approaches 0, they both equal 0, this is 1 times the number in front. That is, this limit is 1. I'm not going to bother to make sure this is correct, or maybe I can. Suppose you have the sine of x squared, which is 25, minus, if x is 5. 5 squared is 25, minus 3 5, that's 15. 25 minus 15 is 10, and then I take away 10. So 5 makes this 0. And then I divide by the same thing. Okay? The two conditions have been met. Both of these are the same. I kind of haven't been saying this, but one of them has a sign in front of it. And when x is this number, 5, both of these equal 0. That's enough for me. That's 1. If I now go and put a 7 in front here and a 13 in front here, well, that's the answer. 7 over 13. Okay, let's do some limits that do not have signs. Oh, let's do this one first. Suppose you have the limit as x goes to 0, say sine squared x over x. Whenever you have a trig function and the top and the bottom is just x, you want to get a sine x on the other side of the division line. That is, I'm going to think of sine squared x as sine x times sine x. And I'm going to divide one of them by the x. A limit of the product is a product of the limits. That is, this here is the limit as x goes to c of this function, sine x over x, times the limit of that function. The first limit we know is 0. Excuse me, is 1. The second limit is sine of 0. Just substitute 0 in. Sine of 0 is 0. 1 times 0 is 0. And that's the answer. This top limit is 0. Think about what would happen if you had sine of x divided by x squared. Think what that should equal. Suppose you have cosine x times tangent x over x, and you want the limit as x goes to 0. Whenever you have a trig limit and you have x alone, get sine x above it. If x is in the bottom, get sine x above it. If x is on the top, get sine x below it. So what I'm going to do is just that. Here is my x. Cosine x, I can't get that to have sine x's. The tangent x is sine x over cosine x. Here's my tangent x on top, here's my cosine x on top, and here's my x in the bottom. So this is just the limit as x goes to 0, sine x over x times, now this is 1. Okay, that's it, it's 1. Sine x over x times 1 is sine x. So this integral is good old 1. Sine x over x is not 1. Sine x over x as x approaches 0 is 1. I can't stress it enough. If you have an integral, a limit that involves trig functions, and either the top or the bottom has an x, get a sine x on the other side of that division line. Suppose you have this limit. You have x, trying to make up a good one. Okay, the only exception to that rule is if you have 1 minus cosine x over x. you should know that the limit as x approaches 0 is 1. Just for the record, if you multiplied the top and bottom by 1 plus cosine x, 1 plus cosine x, which is allowed because you just multiplied by 1. The bottom has x, and it also has 1 plus cosine x. And I'm sorry, I forgot to write the limit in front. Make believe it's there. Now the numerator is the conjugate. 1 minus cosine theta times 1 plus cosine theta. That's 1 minus cosine squared theta. But you're supposed to know your identity. That's sine squared theta. Shorthand notation. Sine squared theta plus cosine squared theta is 1. Bring this to the other side, and then sine squared theta is 1 minus cosine squared theta. That's just what I said. I'll put 1 sine x here, and I'll put another sine x here. The limit as x goes to 0 of this is 1. The limit as x goes to 0 of this, well, sine of 0 is 0, and cosine of 0 is 1. You have 1 times 0 over 2, or 0. So even if you didn't remember that this is 1, you can still get it. Also, you can use L'Hopital's rule. So suppose you have x in the bottom, and I don't know, you have secant x on the top, and you want the limit as x goes to 0. Okay, if you directly substitute, well, you're getting 0 on the bottom, and remember, secant is the reciprocal of cosine. Cosine of 0 is 1, and 1 over 1 is 1. So you get 1 over 0, which is undefined. If you wanted to use what I said, x goes to 0. Well, there's secant x. The secant x is just 1 over cosine x. Now, if I put sine x on the top, I have to put sine x on the bottom. This limit is 1. So if you have a product, with limit in front, you can take the limit of the first factor and multiply that by the limit of the second factor. The second factor is 1 over cosine of 0 times the sine of 0. Cosine of 0 is 1. The sine of 0 is 0. So you have 1 times nonsense 1 over 0. Well, that's undefined. That's undefined. Alright, that finishes their lecture on trigonometric limits.